Hello, guys. My name is Hamses, and it's a pleasure to be a part of this year's Tech Week. I am a computer engineer, Red Hat certified architect, and PhD student. Today, we're going to talk about my 10-year career, which was mostly done in Linux infrastructure. I'll tell you about some of the concepts and technologies that I've worked with and how automation is shaping our future. So let's put the presentation on. All right. So what is this? This is a presentation containing personal views and recommendations about IT infrastructure in general, an overview of some projects and tools I have used during the years, an insight about how automation is pushing us forward, and here's a bit of a legal disclaimer. These are my personal opinions only. I'm not talking on behalf of any company or organization. When I watch presentations, I always get curious about the speaker's background. And most of the time, they don't talk about that as much as I would like. So now that's my turn, let's be specific. I have studied computer engineering at Instituto Militar de Engenharia, and then a couple of years later, I have done my master's in computer science at Universidade Federal do Rio Grande do Norte. And now I'm finishing my doctorate at the same university. So I like to start at the point that graduation is coming. It's good to make a review, thinking about what you liked or not, the courses on which you did great, and the ones that you did not. This can give you two hints. The obvious one is a feeling about your preferences. The other one is your weak points. And during your career, you should always be mindful of those points and work on them. For example, if you start working on operations or infrastructure, thinking that you won't need that knowledge, you are wrong. Automation nowadays is asking us to program how servers and services should be configured. And we do this by writing code. You see, because IT is a very broad field, you will, you will always need a good overall understanding to be able to deliver good solutions. Talking about my first job, which was a little much about finding myself. I was an Army engineer officer for a year and a half, and during this time, I worked as project manager for local wide and metropolitan networks, and after that, I was head of the PMO, which oversaw all network projects. I also worked for a couple of months as information security officer. My activities would be design, plan, and implement network projects, and that involved doing some AutoCAD design, defining the materials, and planning the whole thing until the end. Sometimes I had to coordinate with contractors to execute the plan in the field and supervise them. I also wrote some chapters of the unit's ISMS, which was a broad set of documents defining how we would identify, evaluate, and treat risks such as unauthorized physical access to facilities or network incidents. I also did teach some classes in technical support to prepare new personnel to work on the help desk of the unit. I did learn a lot on this first job, but I wasn't doing something technically challenging. You see, my university is the top engineering school in Brazil, but I felt that my course was way too theoretical. The classes I liked the most were network related, and in my graduation project, I used Linux and I liked it very much. My preferences were not really related to managing and planning. And as I started to think about leaving, these questions came to mind. So, are you learning, doing what you like, liking what you do, comfortable with the routine, aligned with the values, okay with external factors? So, in my case, I was learning, but I wasn't doing what I liked. I was, though, liking what I was doing. I wasn't comfortable with the job's routine. I had to do many activities unrelated to IT. I was aligned to the values, but I wasn't okay with the external factors. I had to move to a new city to get this job, and I couldn't adapt myself to living there. And this was the decisive point. So I was 3 out of 6. And this is me in this picture. I don't really like change, but we all have to know when it's time to look for a new challenge. So, a new challenge. After the army, I moved to a new city and I started working for Petrobras, one of the largest energy company in the world and the biggest company in Brazil. I still work there, but I had two very different moments. This is the first of them. I was part of a team that provided end-to-end support for Linux and for users with scientific profile. The guys who had to analyze data from field explorations in the sea to find oil and gas. This interpretation was mostly done with Linux running on workstation servers and clusters. My team was a regional one, but it was responsible for running everything for these users. So when I say end to end, I mean that you are responsible for simple things like setting up a keyboard or complex tasks like recovering a stuck job on a cluster. This was a very rewarding time and I learned a lot. I was very lucky to have a team to um, taught me very well, and I am very grateful for them to give me space to grow. My main activities would be supporting RHEL and CentOS systems to install, configure, and maintain workstation servers, clusters, and applications. Support some network services like DHCP, DNS, NIS, and NFS. We also supported clusters, which is a group of servers that work together to deal with high workloads. In our case, mostly softwares of seismic interpretation. I also did a bit of hardware support, including some data center operations. Okay, guys, so during this time, I was able to help my team by deploying a systems management solution, and I'm going to talk about it now. This illustrates our day-to-day, activities. We install systems using the ISO media, configure those systems with softwares and security policies, and the system starts its life. A key point was knowing the inventory, how many workstations, which versions, with um, and things like that, which serve, how many servers, where they are, and we did that manually using a wiki software, which is not ideal for this task. We also um, needed to monitor if systems were updated, and least but not last, we maintain the systems, providing support to users and applying patches and bug fixes. When I arrived, the installation process was good enough. For installing systems, we used a standard Kickstart file. This is a text file containing all the instructions to redo a manual installation, but in a completely automated and unattended way, changing just the hostname. We just have to boot the system using the media, and then we make the installation read the Kickstart file. After that, the installation starts itself and runs until the end. The second process was also good, but not ideal. It was a shell script that received some input regarding the purpose of the system and then did all the configurations needed. There was room for improvement because we had to manually run the script after the end of the installation. And those three activities needed work. We had to find a way to improve them. They were mostly done in a manual way. So the solution was an application called Spacewalk. Spacewalk is a platform that aims to concentrate all those activities for managing Linux systems. You register your machines only once, and after that, you will always know your online inventory, which version are running on each system, if they are updated or in need of a reboot, and things like that. And now, on top of all of those features, we could apply patches and run remote commands on many systems at the same time through a web interface. This is a print of the Spacewalk overview page, where we can already see the most critical systems in need of updates, system groups, and recently registered systems. After some months working with this new platform, we were also able to integrate the first two boxes into it, making the Kickstart file run the shell script itself. The platform became our kind of one-stop shop for managing our systems. Everything was better and faster to solve. Just an example, before the solution, we needed 4 hours to deliver a workstation to a client. And after Spacewalk, this time was reduced to 30 minutes. And just information, Spacewalk was the upstream community project for the product called Red Hat Satellite 5. Both of them are now retired. This was 6 to 7 years ago. And now talking about my second moment. As you recall, our team did everything Linux for a group of users. But our reach was regional. And a couple of years ago, the company decided to end those regional teams. The new model, was to create specialized teams that wouldn't do everything, but they would be the experts on what they would do. So our team became the responsible for Spacewalk and Red Hat satellite services for the whole company. We started to work with automation and also to educate the other teams on Linux and automation. Today, my main activities are the development of code to automate ticket resolutions, the integration of systems, making a system communicate to another in a secure and automated way, the development and quality assurance of standard RHEL and CentOS images. We also maintain a set of installation methods. We have now custom ISOs and an installation by script method, which we created. And since we support Red Hat Starlight, we also run the release of updates for all RHEL and CentOS systems of the company. Okay, sorry. During this year, I was able to deliver a pretty cool set of resources that enable the company to develop code to automate the resolution of tickets or requests. So this is the scenario. We have the IT service management portal, which is basically a web system where someone can open a ticket or make a request to an IT team. Then the user goes there and open a ticket to an IT team. Someone of the team takes the ticket and after some thought decides that 4 tasks are needed to resolve the ticket, and each task should be done in a different server. So for doing the task 1, the IT guy needs to access the server A, and so on until he completes the task 4 by accessing and modifying the server D. Then he goes to the ITSM portal and close the ticket. So think about that. What if the IT guy who solved the ticket had some code to do all the tasks without him having to access those systems? So now let's envision this. The user opens the ticket, but instead of a human, an automation platform receives the ticket. Then it uses some code developed by the IT guy, runs the tasks, and closes the ticket. This is an automated ticket resolution. The benefits of it are enormous. The IT guy does not need to worry about tickets anymore. He is now free to work on some other things that are more important. This one code he has created will now resolve many tickets without him even knowing it. We are doing this today using Ansible playbooks as code and the open source project Ansible AWX as automation platform. Now let's talk about Ansible. It is a software, but I like to see it as a type of language. Think English for machines. It is goal-oriented, meaning that you describe the desired state, not how it's done. For example, if you want to install a YUM package, you type the name of the package and the state of it, which can be present, absent, or latest. When you run this task, the machine will be configured to have the package in the state that you describe it. It's a bit of mind shift. It is um, open source and modular. Ansible is multi-platform, going from Linux, Windows, and even network devices like routers and firewalls. It has many integrations, including Azure and Cisco. About the Ansible components, it's pretty simple actually. We have a control node, an inventory file with a list of hosts, and we call those hosts the target nodes. We have a playbook, a YAML file composed of plays. Plays can have many tasks, and each task is a call to a model. The idea is we run the playbook on the control node, which will send tasks to be executed on the target nodes. And now let's do a demonstration. In this demonstration, we will install a CentOS virtual machine from the ground up, and then we're gonna take a look at the Kickstart file. After that, we will install Ansible and create a project to deploy a web server on the same machine. So for demonstration purposes, the control node would be also the target node. Let's play it. Okay, let's start by booting the machine with the right ISO, right ISO media. Let's fast forward a bit. System is booting up. Now I'm doing a manual installation so we can have a look at the Anaconda Kickstart file at the end. The host name I chosen was control.example.com. Now setting the root password. It's starting to install the packages. Let's go forward a bit. All right. Okay, we're now closed. Okay, complete. Now we unmount the media and then we reboot. So we log in. First, check the IP address. Now, let's be extra sure the HTTPD package is not already installed. Let's take a look at the repositories. And here is the Kickstart file. So here we have everything the ISO media needs to do to redo the installation we have done in a completely unattended manner. So these are instructions. And of course, we have an extensive documentation about Kickstart, and we can edit this pre-configuring many aspects of the system. Now we are enabling the FL repository. It has Vim, the editor I recommend to use, and the Ansible itself. Now we install Vim, the editor of choice. After that, let's fast forward. Here I am creating a configuration to help us deal with YAML files with Vim. Okay, some indentation configurations and things like that. Now we install Ansible. And we create a directory for our demonstration project. First, we create a config file setting it up who is our inventory, which would be a file, a local file called inventory. And in this inventory, we are going to configure our target node, which, as I said before, would be also our control node. Now I'm generating the SSH key pairs. Remember, because Ansible runs over SSH, we have to configure, it's a best practice to configure SSH with private key and public key without a password from the control node to the target node. So we can run it in a completely automated way. And here I made a mistake because we needed to have the full host name at the inventory, and then I had made another mistake, which was the IP address of our machine control. The end is 167 and not 7. Now we test again. This test, sorry, sorry about that. Okay, this test is using the ping model just to test connectivity between control and target, which is basically on SSH to localhost, right? So, summing it up, we have a config file, an inventory, um, pointing to our machine control. Now the IP address is right, ending with 167. And now we're gonna write a playbook. Okay. So let me fast forward a bit. We set the name of the play. We set on host who is the target node or target nodes. It can be a group also. And now we are using the yum module to install a package. See that we just describe the state present. Now we are configuring FireOD so our services after installation don't get blocked. CentOS 8.2 has FireOD enabled by default. And now we restart the services. So we do a loop. We use the servicing module, and as parameters, we put a loop over an array with FireOD and HTTPD services. The elements of the array are referenced by item. Now we close. We take a last look before running. Let's put the IP address and be extra sure that nothing is coming up on the browser. And now we run our playbook. Okay, let's test. And okay, we have the full page of the Apache HTTP server, right? Now let's customize it a bit. Let's create an index file. We can do this using the line in file module. Hello from the inventory host name, and we set the path of our index file. rerun it again. And a cool thing is when you run a playbook again, it doesn't redo things that are already done. So, sorry again. Here. So, as I was saying, when you rerun a playbook, if the state is okay, it doesn't redo anything. So it is safe for from this point of view. And now we have a customized index file. So after the demonstration, let's now talk about Red Hat certifications. They are all hands-on, performance-based, and proctored exams, meaning that no multiple choice questions. You have a list of tasks to be executed on a set of virtual machines in 3 or 4 hours, depending on the exam. During that time, someone will be watching you on a camera, and you gotta make 210 points to pass out of 300. And those are the levels. The first one is the system administrator, which have to know how to make local configurations like file services, permissions, users, and things like that. The second one is engineer, which needs to know how to work with both client and server machines, now using automation techniques such as Ansible, shell scripts, and things like that. Then we have the specialist exams that are specific to some products or technologies like Ansible or Red Hat Satellite. They can also be about advanced Linux skills like security or performance tuning. And the highest level is the architect, which is not an exam, but more of a title that you get when you complete the set of system administrator, engineer, and 5 specialist certifications. So here are the ones I have from the bottom to the top: system administrator, engineer, and 5 specialists. Security, systems management related to Red Hat Satellite, OpenShift related to containers, Ansible automation, and Ansible best practices. And at the top, the architect badge. And here I have found the number of certified professionals in Canada, Brazil, and in the US for each certification. We can see that there's a limited number of certified professionals in Canada, and you can use that to your advantage. I'd recommend the system administrator to all of you that have interest on infrastructure or Linux itself. So some closing thoughts summing up my experience. Patching is critical, and normally it means downtime because just a fraction of the applications have high availability features. Over time, soft skills like teamwork and communication are more important than technical knowledge. Linux today is the de facto standard for servers, so be prepared. Fail fast, recover quickly. servers should be treated like cattle, not cats. We gotta be prepared to deploy new systems as quickly as possible, and we should not get emotionally attached to our servers. And believe me, that happens. The DevOps culture is changing the field for good. We now need less boundaries and more integration between the IT teams. I like to leave a message for you guys, which is discipline is freedom. The meaning is that if you have discipline, you will always find motivation. And with motivation, you will always be free to accomplish your goals and your objectives. And that was it. If you have any questions, feel free to reach out on social media. This code points to my professional profile, and I'll be happy to answer your questions. Thank you so much, and be safe.